Welcome, everyone. Thank you very much for showing up and learning about SIG Apps. I'm fully aware it's Friday afternoon, and the one thing that is on everyone's head is I want to go home. I'm exhausted. The conference was awesome, I hope. And but you're all probably ready to just finish it off. So I do hope that the presentation will be a strong finish. So let's start. So who we are, my name is Maciej, as I already said, and sadly Janet and Ken were not able to join us today at the stage. The three of us are in charge of the SIG Apps, and for the rest of the presentation, I'll try to walk you through what the SIG application group is, what we do, and what are the plans for the upcoming weeks and months. So how to reach us, that's probably the simplest and the starting point. We are meeting every other Monday, and the times, depending on your time zone, are listed on the web page. The best option also is to reach out on Kubernetes Slack, SIG Apps, or a mailing list. If you remember from the past, we used to have a Google Groups mailing list. We migrated this over to Kubernetes Managed. It's also easier to remember. It's just sigapps@kubernetes.io. So what does the SIG Apps does? I will admit that the SIG Apps has a pretty broad area of impact into the Kubernetes project. Theoretically, we are always welcoming and inviting a lot of the people to show up and present to our group what you are doing. Even though primarily the SIG or special interest group is evolving around what the Kubernetes core controllers, and I'll cover a couple of them in a moment, but if you're thinking about it, that's like deployments, that's job, cron jobs, daemon sets, stateful sets. Even though we are primarily responsible for the following controllers, we are always open to hearing from other people in the community using Kubernetes, what kind of issues that they are struggling, what kind of problems that they are solving, how they are solving them. Also, if you are seeing limitation in the built-in resources that the SIG is responsible for, we are more than happy to hear from about your problems, how we can solve, because there's a lot of discussion that has been happening over the years. Maybe we'll be also able to point you in the right direction or connect you with a different group, different team, different person that was already struggling with a similar problem and how they resolved it in the past. Aside from that, there's also something that we do every single year. We're doing like a summary information about what the special interest group of ours did. You can find the links in the presentation. That is also linked in the schedule. So, like I mentioned, over the past 12 months, or even before, I'll jump quickly, in the annual reports, if you're also interested in what the SIG Apps was doing over the past 10 years, a little bit of in-depth history of our special interest groups, as well as the entire Kubernetes project. In the annual reports, there are two presentations that we did last year during KubeCon in Paris and in Salt Lake City, which was going in depth into the history and evolution of various APIs, various resources, and the problems that we encountered along the way. So if you're interested into that, I will also welcome you to have a look at the annual reports or just look for the presentation from past KubeCons. But now focusing on what we are currently working on and what we've been in the progress for the past 12 more or less months. Some of those features, there are in the parentheses information about the versions. Maybe you've already had an opportunity to play with them. If you have any feedback, let us know. Okay, I'm alive. The poster not necessarily. So quickly, I'll go through them, try to explain. If you have any questions or suggestions, let me know. We will have, I hope, a couple of minutes after this presentation. I'll be also hanging out around the hallway for a couple more minutes if you have any questions. So let's quickly go over the stable features that we released over the past year. The first one was an interesting one. So pod disruption budgets, the way that they were originally created, the goal of the resource is to protect your application through labels and selector labels and number of applications. It will always ensure that the number of specified replicas is available, and during eventual draining of a node, it will stop or prevent draining from continuing until we have a new pod replacing. There was a tiny little bit, and we had multiple arguments back and forth with regards to how the pod disruption budget was counting the pods. Originally, it was counting both ready and not ready pods. So assuming, and I do hope that each and every single one of you have proper healthy and readiness pods defined in your pod, once a pod is ready, as in past the readiness, there is a difference between a ready and not ready pod. But before this change, we were counting both equally. Normally, only the ready pods should be counted towards your pod disruption budget. But because Kubernetes, one of the important goals is making sure that the backwards compatibility is not being broken, we needed to introduce another field in the pod disruption budget, which explicitly allow you to pick one solution or the other. And the addition basically there was that I'm only interested in the ready pods in my PDBs to count towards the disruption budget. That means if your pod is not ready, it can be evicted, which is important in some cases and allows you to save extra resources. I know that we found it very useful in a couple of interesting cases. Another one was actually long overdue. A lot of users came to us with the request to be able to randomly pick pods within a replica set when we were downscaling. Normally, there's a hefty algorithm that basically tries to pick the newest pods created and replaces those, but that's not always the best solution, especially if you're rolling your application and you're actually trying to replace older with new ones. It would actually pick the newest one first. Currently, we've implemented a little bit more randomization in the algorithm, and that allows us to have a little bit more control over how the rollout is progressing in the replica set. Moving on, that was an interesting use case for StatefulSet. If you are aware, each and every single StatefulSet defines basically pods, and each pod has a particular number in a StatefulSet. And it's always starting from 0 up to the number of replicas. For the cases where you're trying to migrate your StatefulSet from one cluster over to another, you actually want to maintain the numbers consistent when moving from one to another. But in parallel to that, you want to still maintain the entire StatefulSet as a single unit watched from outside of the cluster. So this feature specifically allows you to say, oh, my replica set should start numbering from, let's say, 3. Not from 0, but 3, because the 0 and 1 already moved to the next cluster. And this way I can slowly move one by one pod from one cluster to another, or for storage, or for various migration. Primarily, the migration was the main use case that we've been investigating. The last one in the GA, I believe that's the last in GA. Of course, it decided to blink down. So the last one, SIG Storage, actually, the people within SIG Storage reach out to us. Normally, when we are creating a StatefulSet, originally when we created the StatefulSet, we decided that we don't want to break users, and we don't want to touch the PVCs created by the StatefulSet. This was to ensure that the data that is being managed by the StatefulSet is secure for the entire lifetime. So we never do anything, and if you were either removing your StatefulSet or migrating, whatever you were doing, you were responsible as the owner of the StatefulSet to remove the PVCs after the StatefulSet was removed or eventually migrated. There were some use cases, and with the help from the SIG storage, we've actually implemented an explicit policy, so you have to be configuring your StatefulSet and clearly point that during either a scale down or entirely during a removal, it's completely fine to remove the PVCs alongside the StatefulSet. So this is your explicit decision to touch the PVC or leave it as is. And if I remember correctly, we even went as far as there are separate configuration for scale down and separate configuration for delete. So you can specifically say that it's okay to do it only when removing, or also during the scale down. So you have that kind of flexibility. Oh, actually, we have a lot more related GA features, and a lot of the, if you notice, a lot of the work around the SIG apps currently, and especially within the past, I would say 2-3 years, has been driven heavily by the working group batch. So those are people that helped us ensure that any kind of workload, whether that's AI, ML, or any kind of high performance computing, that they are feasible in a Kubernetes cluster. So a lot of work around the batch area, primarily the jobs, introduction of index jobs, or improvements in the performance of handling jobs is coming from the batch working group. So a couple of examples, elastic index jobs. So index job, if you've never heard about them, it's basically the ability to specify. It's a combination of that. That will be probably the best analogy. It's a combination of a job and a StatefulSet, meaning that each and every single pod in an index job has a specific index. If that index fails, a new pod will replace the same pod with the same number, so it will have a stable DNS also associated with it. If I remember correctly, we're also injecting environment variable with information about your index in a job. The elastic part in this particular feature allowed us to scale or modify the index job, but only when we are modifying both the completions and parallelism. Because if you remember properly, the job allows you to modify a parallelism, which is how many pods are executing particular job at any given point in time. And that is basically to allow us to dynamically scale up and down the job, depending on how busy our cluster is or what's going on with our clusters. So, and completions are usually fixed in place at the moment when the job is created. For elastic index jobs and for some use cases when using index jobs, primarily again in the area of MPI or HPC computing, it was reasonable for us to say, oh, I want to create this many pods, but once we reach a completion that is not fully defined at the moment when we are starting the job, or that is defined outside of the Kubernetes cluster within the job itself, we are able to modify completions and parallelism together. But it has to be the same number and modified at the same time. An interesting thing, and that's actually a very simple feature, but a lot of users have asked for this thing for quite a while. When we are creating jobs from within a cron job, a lot of users wanted to have a clear information when this particular job was meant to be created. Within a cron job, there is an ability to decide that, oh, if something happens in my cluster, for whatever reason, I don't know, whether a kube controller manager goes down or you turn off the cluster for the night, I'm not asking, I'm not judging, whatever you want to do. And the cron job controller kicks in again, you can tell the cron job to, oh, if I'm delayed with my schedule for this long, it's still okay to create the job for me. That's an explicit separate feature, and a lot of people wanted to know still within the job created, how big the delay is, what is the actual time why my job should have been created. So we're currently injecting an annotation into a job so you can inspect that information and eventually do whatever you're pleased with that date. The next one is also very similar to the previous one. This time around, and this is what I was talking about, we're injecting an annotation with information about your pod index in a both StatefulSet and in an index job, which was a request from multiple users, again, similarly, from primarily coming or gathered around the batch working group, because they want to know that, oh yes, I'm index 5. And eventually what they want to do with that, they frequently will. I had an example that I built like multiple years ago when I was initially introducing jobs. You can chunk your major, for example, image processing pipeline into chunks, and you actually want to know that your index in the pod is number 5, because the number 5 bucket is the one that I have to pick up. So you don't have to manually inject that information into the job, but just read it from the annotation. And a couple more GA features, and something actually that is landing in this new upcoming Kubernetes release. One is a backoff limit. So within a job, and that applies to every single job, we allow you to say, oh, I can retry a particular job a couple of times. But that limit is specified as a global limit for the entire job. So if I'm running, I don't know, a couple hundred or a couple thousand, and my backoff is, and the default is 6, if I remember correctly, that might not necessarily be enough, and there will be it'll always be at a global scale of the entire job. In some cases, especially for the index job, you want to be a little bit more descriptive, and you want to have that kind of a limit applied only for a particular pod. This allows you to, if you're running your job against several clusters, and one of the pods will land in a faulty node, for example, that one faulty node will only kill this particular pod and get it replaced, rather than killing the entire job because you reach your backoff limit. So it's always currently calculated per particular index of a job. The next one, job success and completion policy. Before that, we always said your job has to complete and it has to finish everything. Meaning all the pods in a job have to reach a completion status, with some exceptions. Currently, we will actually allow you to define an exit criteria, which will allow you to tell that a job is finished sooner than actually all the predefined completions number is reached. So that's also in some cases useful for the batch use cases. So an interesting feature. Another batch-related topics, primarily this is coming from people that are working on Q. Does any one of you heard about the Q project? The Q as in written by K-U-E-U-E. It's a project, one of the SIG Apps sponsor project, which helps with queuing the work, primarily for the batch workloads again. Their use case that they have, and this is not the first time where we have a similar mechanism in Kubernetes cluster, endpoint slices and IP addresses is a similar. We're basically introducing an annotation which says this particular job is handled by an external controller. Usually in the annotation, you put the name of the controller. But that is assigned to the built-in job controller within the Kubernetes cluster, not to run the job at all. I know it looks super simple from the outside, because from outside it's, oh, I'll say just this and the controller doesn't do anything. But actually, when we allowed third parties or external job controllers, what we wanted to ensure is the correctness of the statuses reported by external controllers in the job status. So a lot of the effort that we put into implementing this particular feature was around ensuring that the status validation for a job object is properly defined and encoded in the Kubernetes API server to make sure that not only the built-in job controller is behaving in a specific and consistent way, but also to force other users or authors of an external job controller to also make sure that the controllers abide by the same rules and are following the same limitation. This way, users of the job object can ensure that whatever they're using, the built-in or an external controller, they get the same consistency with regards to this to the job status. They primarily, their main use case, how they are using is in a case when you're running in a multi-cluster environment, you can have a primary job defined in your hub cluster, which serves as a central point for holding the information about the status, but the actual execution is being mirrored or placed in subclusters, or even can be divided into multiple different clusters. So that's the kind of approach that they have, in which case, obviously, in the hub cluster or in the central cluster, they only want to mirror the information about the status and the progress of the job, but the execution is happening somewhere else. Okay, so what's in our pipe for the next couple of releases? The job pod failure policy is an interesting development that has been in the works for, I would say, more than a year. It defines entire sub-language within a job, which allows users to define when my job or when specifically my pod should be retried or not. Currently, we have mechanisms describing exit codes, conditions, and conditions and exit codes coming from a pod, which allow you to say, oh yeah, this is actually an expected failure, and it'll be fine if it finishes, or this is not something that I want to, or this is an error card that I did not expect, and I should probably just retry this particular pod to be rerun. Another interesting topic that we have in the books for a couple of months, and we've been going back and forth, is normally when you are rolling your deployment, it will try to assuming that you specify the correct search and max unavailable, it will try to fill in and replace your pods as quickly as possible. Like I said, to match your search and max unavailable configuration for your deployment. But there are some cases, for example, if you're running at your quota or very close to it, where that kind of replacement is not possible. So we want to be a little bit more mindful with regards to not pushing the limits as far as we want, and explicitly request that only bring new pods when the previous one reaches a termination phase. So this way we will allow you to replace one by one or like multiples in parallel, in which case if you're at quota, let's say you have 5 pods and this is your quota, I will be only allowed to create the new one when one of the existing 5 will go down, as in it will reach a terminating state. So we have a couple of use cases described in the document, particular for that feature. So that's also, if you have any thoughts or ideas around implementation of these, we are very open to the feedback. The third on the list is something that is actually that has been discussed this week numerous times, but also in various special interest groups within the Kubernetes project, and which includes architecture, Node, autoscaling, SIG Apps. I can't remember what else, but there were like multiple SIGs involved. The idea is currently nowhere in Kubernetes node resource or anywhere in the built-in resources, we have the ability to express that we are in the process of draining a node, how long it should take care, when it should be able to just forcefully start forcefully removed, which pods can and which cannot be forcefully removed. Yes, we have PDBs, but PDBs have a very limited surface because they will basically prevent the eviction from happening, but they will not allow you to either delay the eviction, or eventually, if your eviction process requires a specific amount of time for moving your workload from one pod to another, that information is not encoded anywhere. And we are thinking and discussing how we could in what better way we could describe the entire draining process and eventually introduce external actors which could help us with draining the node and eventually moving application from one node over to the next one. The last one on this slide is something that I'm personally very ashamed of, because that's kind of like a topic that still has actually a 3-digit enhancement number, which means it goes way in the back. I forgot to check the actual date. But the enhancement is probably more than like 4 or 5 years old. The idea is introducing max and available for StatefulSet. If you've ever used the max and available for deployment or ReplicaSet, which basically allows you to set, oh, it's okay for my application to reach this number, and this is either a number or a percentage of unavailable pods during a rollout. This basically allows you to speed up your rollout to a newer version. We wanted to introduce, and we started introducing this functionality into a StatefulSet, but the problem is that each and every single enhancement in the Kubernetes, each and every single feature in Kubernetes, when it's being introduced, requires a very tight information presented to the cluster administrator that the feature is working correctly or is not. And for the past 2 or 3 years, we are all struggling to come up with a reasonable metric that will express the rollout of a StatefulSet. Because for deployment or ReplicaSet, that's pretty easy. A lot of those controllers basically will spin up as many pods as you allow, and it's done. There's no external parties affecting the rollout process as in from the controller point of view. In case of a StatefulSet, at least the one where you're rolling one after another, I'm not talking about the parallel pod mode rollout, because that's obviously that will allow to roll out multiple pods. But in a case where you're rolling one after another, the actual time required to start the application will significantly affect how quickly you can roll the entire application. So with that in mind, we cannot easily express the information how long the rollout for that particular or other application would take, because those numbers will differ from application to application, and that basically means that the metric is not reliable and will not allow us to quickly say, oh, this actually, the number, if your deviation is more than 10% from the norm, that's bad or good. And we are not able to express, yes, the feature is working correctly, or no, it's not, and you should probably roll out to the previous version or basically turn the feature off. So this is where we're currently dealing. There are also problems around, like you see in the picture, we lost the main contributor that was working on this feature. They were moved to work on different topics, so we're looking for new volunteers to help moving this particular feature forward. Okay, I'm literally right on time. Those are the information, how to best reach us. I will be in the hallway for a couple more minutes. If you have any questions, I'll be able to answer them afterwards. Thank you very much.